So currently it's just doing a smooth interpolation from the world final foot transforms, and it's moving towards where the foot should be from the input. But instead of using this value, what we're going to do is get a predicted value for where the foot should be. And later on, we're going to make some improvements to this interpolation. So it actually interpolates from the position it was when the foot unlocked. So we're not going to use the world final foot transforms. We're going to use the locked position. So then we can do a smooth interpolation. We have more control of the blend between where it is from where it started to where it wants to be. Because currently we're just constantly updating this value, and we kind of lose track and lose a reference to where it was when it first lifted off the ground, which makes it a little bit more complicated for doing things like making the feet lift up as they're halfway through the path and other things that we might want to do. So what we're going to eventually do is switch this from the world final foot transforms to an actual locked transform. So we'll make an array where we save where it was locked. But for now, we can just keep using the world final foot transforms. So instead of interpolating to where the foot is based on the input pose, what we're going to do is do it based on a new variable, which is going to be called predicted foot transforms. So make sure this is a global variable, not a local variable. Set it to a transform and make it an array. And I'll compile and save before renaming. And I will right click, rename this. Predicted foot transforms. Compile, save again. And we're going to create a new function to do the prediction. So in the rig graph, what we're going to do is we calculate the velocity because we need the velocity for this calculation for the prediction. We need to know how fast the character is moving. We also need to know where we are in the cycle, so we'll do it after this calculate cycle, but we need to do it before we move the feet transforms. So somewhere between here, we're going to have a new function. So let's create a new function. So I'll create a new function here. We'll do update foot predictions. And we can move the entry and return nodes away from each other. Compile. And in the rig graph, where I mentioned between the calculate cycle and move feet transforms, we're going to drag in our update foot predictions node. Connect that through the execution paths. Compile, save. Now we're going to go to our update foot predictions, where we're actually going to do the calculation to predict how far ahead the foot should be predicted based on the velocity. So inside our update foot predictions function, what we're going to be doing is we're going to be looping through all of the feet. So we'll drag in our foot names reference, get foot names. From this array, we do each, so for each. Entry goes into the execute of the for each, and the return, once again, this needs to be on complete so it doesn't return more than once. And now in the body of the loop, what we're going to do is decide how far ahead to predict each individual foot. So what we want to do is we're going to keep updating our predicted foot transforms array. Currently, this is empty, so we can't set the values. If we try to just set at this index, it wouldn't exist. So what we need to do is go to the rig graph. So in our rig graph, in the construction event, which runs once, it loops through all the feet, adds entries to this array, adds entries to this array, adds entries to this array. We're going to do the same for our predicted foot transform. So drag in the reference to get, and we're just going to add. And we can leave the element blank for now. There's no predictions because nothing's moving. We haven't calculated the prediction. What you could do is you could plug this in as well. So I'm just going to plug this in. So this is the world space location of the feet where they are currently, just so that the default value has something there. Then we're going to compile and save. And now we're going to go to our update foot predictions function. And we drag in a reference to our predicted foot transforms. Do get set at. And we're going to set it at the current index that we're looping through. And now we just need to do the calculation for what this transform should actually be. So we need to do the prediction and then plug the calculated prediction into this element.